our last lesson here is called maximum flow, minimum cut. So we're going to look at the maximum flow first and how that works. So the maximum flow or flow capacity of a network can be found by considering the capacities at each vertex and tracing along the network diagram from the source to the sink. To keep track of the flow through the network, we cross off the weights as we proceed through the vertices. So there are a couple of different ways to teach this, and I'm just going to show you the one that I like. So basically what we're doing is we're looking at going from the source to the sink and what's the most that we can get flowing through this network. Remembering that we need to consider what's coming in and what's going out at each vertex. So I'm going to take you through some simple ones first, and then we're going to get a little bit more complex. So you can see here from the source A, we can go up to B and our capacity is 5. So when I do a edge and I've gone through and looked at the capacity of it, I will cut it off and I will write the maximum capacity that can go through. So the maximum capacity that can go from A to B is 5. The maximum capacity that can go from A to C is 21 because they're both coming from the start. Now we need to look further. So from A to B, I've got a capacity of 5. The outflow of B is 8, but there's only 5 coming in. So that means the maximum coming out of here is going to be 5. If we look this way, we've got 25 coming through, but maximum capacity coming out is only 7. So again, this one, the maximum is 7. When we look at what's coming into D, we've got 5 and 7. So we've got 12 coming inflow, but our outflow is 6. So the maximum coming out is going to be 6. So we say for this, the max flow equals 6. Okay, because that's a maximum that can go through that network at one time. Let's look at this next one. So again, we start at the beginning. So between A and B, 6 can go through. Between A and D, we can have 4 going through. That's our maximum. If we then flow through there, we're going from A to B is 6. Now coming out of B, I've got 7 and 10. Now this is where you've got to look a little bit further. So if I've got 6 going through here, 7 coming out, 11 going down, I've got this 4 coming down, but I've only got 3 going out, don't I? So I've actually got enough coming from this 4 to get maximum capacity coming out this way. So I'm going to take that 4 and say I've got a maximum of 3 coming out here. So if I've got 6 coming through here, I don't want to use these ones. They're not helpful. So I'm going to use 6 coming through here and it's going to go through this one over here. So the maximum coming out of this is 6 and I haven't actually used those there. So the maximum coming into E for this one is going to be 6 and 3, which will give me a max flow of 9. Okay, now these take quite a bit of practice, so let's keep going. Find the maximum flow of this network between the sources A and the sink E. So let's do the same thing. So as we're coming out of the source, A to B is 9, A to C is 6. Let's keep going. So if I've got 9 coming through, but I've only got 5 coming out, so the maximum coming out of there can be 5. If I've got 6 coming this way, now I've got 6 coming through, I can only have 4 coming out, but I have 2 left over, so it can go this way, okay? So my maximum inflow is 6, and I've got an outflow of 2 and 4, which gives me 6. So I've got 4 coming through here, 2 coming through here. So now when I look at the outflow of D, it's 8, but what have I got going in? I've got 5 going in and 2 going in, so the maximum coming out of there is going to be 7. So if we change that to a 7, and then we can see what's coming in here. We've got a 7 and a 4, so our maximum flow is going to be 7 plus 4, which gives me 11. Okay, find the maximum flow of this network between source, vertex A, so this one's our source, and the sink, vertex E, sink. Okay, so let's flow through this one and do the same thing. So flowing out, we get a 7 and a 3. As we go through, we can see our 3 comes down through here, but only 2's coming out. So we'll change that to a 2. this one here, we've got 7 coming through. Now, I've got 5 coming out here and 3 here. So what I want to consider is where it's going to help me the most, okay? So 5 and 3 gives me 8, but I've only got 7 coming through. Now, this 5 goes straight to my end, so I kind of want all of the 5 there. I've only got 2 coming here and I've got 4 there. So can I take some down here to go up this way? So let's have a look. Let's change this to a maximum of 5. Now, if I have 7 coming through and I take 5 that way, that means I can make 2 go this way. So let's change that to a 2. Now, if I look at what's going into D, I've got 2 and 2, which means I can have 4 coming out. So 4 through there. So our maximum flow for this one is going to be our 5 and our 4, which gives us a max flow of 9. Okay, now what we do is we take this to add our cuts to it. So we have this theorem called the maximum flow, the minimum cut theorem. This allows us to more easily determine the maximum flow in a network. So what happens is, to make various cuts on the network, then you find the capacity of those cuts by adding the valid edges, and then you compare the capacities of the cuts you have found. Basically what it says over here is that the maximum flow minimum cut theorem, the maximum flow in a network is the same as the capacity of the minimum cut, i.e. it identifies the bottlenecks in the system. Now, you can definitely do that, but it is very easy, especially on a very complex network, to miss a cut. So generally I will teach that even if you've been asked to do a minimum cut, that you always do a maximum flow as well and match them up, because a lot of people find doing the maximum flow a lot easier than looking at all the cuts and working out which one's going to be your minimum. So in these questions, we're going to be doing both. The only thing you have to make sure that you do is when we're doing a cut, we always have to add these numbers, the original numbers. So when we do our flow, can you see how we cross them out? So if this part here was part of my cut, I would have to use 3, not 2. So you have to be very careful when you're doing this, that you make sure you pick the right numbers for your cuts, okay? So it says use the max flow minimum cut theory, find the maximum flow for the source vertex L to the sink vertex Q. So let's just do some cuts and see if we can find it. It's said to be strategic. So what are you going to do to be strategic? If we want the smallest edges, you'd think that we're probably going to leave the big edges out. Maybe. So what we want to do is go through, and there's 2 things I do first. I will always do a cut like this first. These 2 cuts. The cutting off the source to the sink and cutting off the source to the sink. Okay, so let's do that. If I add those ones, I've got 9 and 15, which is going to give me 24. And on this side, I've got 11 and 7, which is going to give me 18. So they are where I start. And then we kind of go from there. I can see that 18 is smaller than 24, so I'm looking for something that's going to be smaller than 18. If that's the case, then I can be a little bit strategic about what I'm doing. So if I have a look here, 14 and 7 is already bigger than 18. So I'm not going to use anything to do with these 2 lines together. If I look at 11 and 6, that's already 17. So again, I can't use those 2 lines together. I can't use 15 with anything that's on the board to be under 18. Okay, so I need to look to see if there's anything smaller. I might be able to go through this way. No, because I've got a 7, a 7 and a 9. Doesn't look like there's going to be any other way with all of these cuts I'm looking at. So if that's the case, I think 18 is it, but I need to make sure. So to make sure, I'm going to do my maximum flow and make sure I'm correct. So if I flow through, that's 9, that's 15. I've got 9 coming through, so I've only got 9 coming out. if I've got 15 coming this way, I can take 8 this way and 7 this way, which is 15. So both of those are going to be at full capacity. And then I've got 7 and 9 coming in here, which is 16. I've got 11 and 6 coming out. Now that's 17 coming out, so I can't make them maximum. This one's going straight to the end, so I want that to be 11, which means that I've got an extra, 5 coming out here. So that was 9 and 7, which is 16, 11 and 5, which is 16. So into P, I've got 8 and 5, which is going to give me 13, but I actually only have 7 coming out. So I'm going to change that to a 7. And then I can see my maximum flow at the end is going to be the 11 and the 7, which is going to give me a max of flow of 18. And we can see that we were actually right with that cut. Okay, so I would always use that to help you. So let's have a look here. Using the max flow minimum cut, find the maximum flow from the source to the sink. So we can see where the source and the sink are, here and here. And again, let's be strategic. So let's do these end ones first. 9 and 13, that's going to give me, 22? 12 and 6 is going to give me 18. There was 18 again. I can see some smaller numbers in here. So I can see a 4 and a 3. So I probably want to use those somewhere. So if I went through here 4, 8 and 3, I could get a number there. Now I do have this going in the opposite direction. So could I use that to my advantage and cut off this way where the 7's not going to be used? So I might be able to do that too. So let's have a look at a couple of those. So if I go through this way here, this 7 is not going to be used. So this one would be 4 and 11. So that's 15. So that's already smaller than the others. But then I just want to check this one here. This one's going to be, what's this one? 4, 8 and 3. So that's 7 and 8. So that one's also 15. Is there anything smaller? I can't. If I go through there, that's 20. Again, they're too big, those numbers. If I go this way, 12 and 3, well, that's 15 again as well. So I'm making a lot of 15s there. So what I might need to do is I might need to do my flow now and just see if 15 is what I get. So let's go and do the flow. 9, 13. Okay, so I've got 13 coming through, 11 coming out, so that's 11. Then I've got 9 coming through. I've only got 4 and, oh no, that 7's going that way, be careful. So I've got 9, I've got 4 coming out, so that's just 4. This 7 doesn't do anything for me because I've only got 4 coming out, which comes from the 9 anyway, so we're not going to use that one. Then let's have a look. I've got 12 there. Can we use this 8? So I've got 11 coming here. So 11 in. I've got 3 and 8 coming out. So yeah, I'm going to use that. That's 11. So 8, 9, 10, 11. So that's 3. I can see I've got 4 and 8 coming in, which gives me the 12. Nice. And then here I've got 3 coming through. I've got 6 coming out, but I've only got 3 coming in. So that's going to be a 3. And then I can see my max flow is going to be the 12 and the 3, which is going to give me 15. So I can see that 15 is going to be the correct one. Okay, so a couple of ideas there, looking for your strategic cuts and then also double checking your answer at the end. Okay, so we'd write for this one, the minimum cut equals 15 because it asked us to use the cut theorem. Okay. Let's have a look here. The following directed graphs show the flow of water in litres per minute in a system of pipes connecting the source to the sink. Use the maximum flow minimum cut to determine the flow in the litres per minute. Now with this one, it's a multiple choice question, so whether you use the flow or the cut is really up to you, but we're going to practice both here. So if we have a look, we've got a 2 and an 8 and a 10. So if I cut that way, it's pretty big numbers. If I cut, I can really only go that way, that way, and that way. There's not much other choice, is there? So let's have a look at each of those. So if we do this cut here, we've got 4, so 4, 10, and 6. So that's going to give me 20. If I do this cut here, I've got 2, 10, and 8. So that's also 20, isn't it? 20. If we do a cut through here, so I've got 4, 10, and 8. That's even bigger. That's 18, that's 22. And if I go this way, I've got 6, 10, and 2. Also, that one's 18. So we think it's going to be 18. So this is where we'll just quickly check. 4 coming in, 2 coming out, 6 coming in, 6 coming out, and 10 going straight through. And we end up with 2, 10, and 6, which gives us our 18. So C would be our answer. So we can do the same thing for this one, the maximum flow from source to the sink. Let's do some cuts first. Again, we can see a 1 here. We kind of want to use that 1, I would say. We can see a 2, a 3, a 3. We've got a 6 in the middle. We might want to avoid the 6s because they're the biggest numbers. So if we went straight through here, that's getting that 6. What if we went through 3, 4, and 3? Let's try that. So if we go 3, 4, and 3, that's 6, that's 10. If I go 4, 5, and 2, that's 11, so that's bigger. I want that 1. What if I go 1, 4, and 2? What's that? 1, 4, that's 5. Oh, that one's 7. Do you reckon they'd be lower than 7? Anyway, let's check. So we've got 4, 5, 2. 4 going through, 3 coming out. So 3. 3 coming out, 1 coming out of there, so only 1. Here we've got 5, that turns to 5. And then we've only got 4 coming out of there. So down the bottom we've got 2 coming. That's only going to be 2 and that's going to be 2. So I think we're right. 2, 2. And we end up with our 1, 4, and 2, which is going to give us our 7. Okay, so this is where we get a little bit more complex. So it says a network of tracks connects 2 car parks in a festival venue to the exit, as shown in the directed graph below. So if we have a look here, we've got a car park here, a car park here, and our exit over here. The arrows show the direction the cars can travel along each of the tracks and the numbers shown each track capacity in cars per minute. 5 cuts are drawn on the diagram. The maximum number of cars per minute that will reach the exit is given by the capacity of. Now remember, the maximum number equals the minimum cut. Okay, so what we want to do, we're not doing a flow on this is crazy. So what we want to do is look at these cuts and work out which is going to be the minimum cut. Now there's something different about this question because here's my exit, which is my sink, but I have 2 sources this time. Now remember, to get a minimum cut, we have to cut the source from the sink. So if I look at this cut here, this source is still on the same side as the sink. So this cut actually is not working. And that's the same for this cut here. It's still not cutting this source off from the sink. So cut A and cut B actually don't even work. So we can take those out. What we want to look at is these cuts here that actually cut off both sources from the sink. So we want to look at what their capacities are. So let's look at this one first. I'm just going to draw on it so that we can see it a bit better. And let's look at what lines. So we're going to cut this line, source to the sink. So we have a 5 there. We're going to cut this line, source to the sink. So there's a 12 there. So I'll go 5, 12. And we're going to follow this line down. And we've got this line here, which is also source to the sink, which is a 3. So for this cut, we've got 5, 12, and 3. So that's going to give me, what's that, 17, 20. All right, let's look at the next cut. So if we're looking at this cut here, Okay, we're cutting this line here. Again, we're looking at the 5. We're going to keep going down. We've got this line here, so we're looking at that 10. And keep coming. Now we've got this line here, but if you look, this one is going from the source side to the sink side, so we actually don't want that one. And keep going down, and we want this one here, which is the 3. Okay, so this one's going to be the 10, the 5, and the 3, so that one's going to be 18. All right, our last one over here. So we've got this 5. If we keep going, we've got the 11, keep going, and we've got the 6. So this one's going to be 5, 11, and 6, and that's going to give me a cut of 22. So I can see that my minimum cut on here is going to be the 18, which is cut D. Okay, so these questions get a little bit tougher. What it's asking us to do here is to look at the flow that's happening and can we make any changes. So it says now that we're able to determine the maximum flow in a network, we're able to analyse existing networks and determine whether the flow is sufficient to meet the demands of various real-life situations. We're able to make recommendations to improve the maximum flow in a network. So the maximum flow in a network can be improved by either increasing the weight on an edge or constructing a new edge altogether. So this is where we get to analyse what's actually happening. So let's look at this one. We've already looked at this one before. It says find the maximum flow on this network by using a minimum cut. So again, we can use the flow if we want to, but let's look at our cuts. If we cut here, we get 19. If we cut here, we get 13 and 7, which is 20, so 19 is the smallest. I've got 2 small numbers here though, so can we cut straight through here and we'll get a 14. The other way we can cut would be here, that's going to be also 20. So I can see pretty easily that that's my cut, and I'm going to get a capacity of 14, okay? Then it says, show the maximum flow of this network. So now what we're going to do is do the flow. So we're going to go 7 coming out, 13 coming out. Out of my 7, I can have 13 coming out, but 7's the maximum, so we'll change that to a 7. Out of my 13, the maximum coming out is a 7, so we've got that 7 as well. And then coming into here, we've got 7 and 7, which is 14, so the maximum coming through here is going to be 14. So our max flow equals 14. Now, the next part of that question says, one road is to be widened to increase the capacity. Which road would you choose and why? So if we have a look at these roads, which one's going to give us a bigger flow? So our final one is 19. So we're losing some flow through here. Is there a road over here that we could increase? Well, this capacity is 13, but I only have 7 coming through. So I could increase this capacity. If I increased A and B and changed that to 13, then I would have 13 coming out and I would get more going through here. The same happens down the bottom. If I have 13 going through here, I've only got 7 coming out. So if I increase this road here, CD, to 13, I could also get 13 coming through there, which would increase this. So to answer this question, we could write both of them. Now, we can't increase both roads. One, because it says one road is to be increased, but also if we increase this road and this road, we'd end up with too much coming through and we'd still miss out. So we're going to write just one. So either road AB or CD can be increased by, how much do we want to increase it by? So 7 to 13 is 5, by 5 to increase the network flow. Okay, so with these ones, we're looking at what's going on and how can we increase that flow to use maximum capacities. Okay, let's try it again. The network diagram below shows the amount of people who can travel from one station, Hornsby, to another central. So that means Hornsby is our source and this one is our sink. Okay, that's the direction we're going. Find the maximum flow of this network using a minimum cut. Now this one's a tricky minimum cut because there's a lot going on here. So let's see if we can work out our minimum cut. If I cut here, I get 300 and 400, that's 700. If I can see some smaller numbers, there's a 70. Don't forget I need to cut my source to my sink. So if I go through here, what have I got? 200, 400, 550, so that's 620, so that's smaller. What if I go this way? No, that's not cutting off my source and sink, is it? What if I go this way? Oh, that's 400. What if I go this way? So I've got 100, 150 and 200. What's that? That's 100 and 150 is 250 plus that's 450 that way. That's the smallest so far. If I go that way, it's too much. If I go that way, it's 500. That's still more than 450. So I'm thinking it's going to be through here. So if I put that one in, let me just put it there and then we'll double check it. So let's do, and it asks us to do a maximum flow next anyway. So let's do a maximum flow and see what happens. So coming out of here, I've got 100, 150 and 200. So it's always the same coming out. So 100, 150, 200. Now, if I flow down this way, I've got 200. There's only one coming in. So that 200, this 400 has to change to a 200 because that's all that's coming in. Okay, let's go this way. Actually, I'm not going to do this one yet because I've got this one coming through as well. So let's go the other way. So if I've got 100 coming through here, 200 there, 70 here, do I want to split it? If I go this way and I put 70 here, that means I'll have 70. That means I could go 30 there. I'd have 70 come back here, 30 come back there. So I end up with 100 there anyway. So I think I might just take my 100 straight through here. So I'll just change that to 100. So now I can see I've got 150 coming here, 100 coming here. I'm not using those at the moment. And so that means I have how much coming out? I've got 100, 150. So that means I've got 250 coming out. So I'm going to change that to 250. So I end up with the 200, I keep pressing the wrong button, 200 and 250. So I've got the 450 coming out. So my max flow equals 450, which was the same as the cut that I had as well, which equaled 450. So we did good. Okay, so the next part of this says what improvements could be made to this network to improve the flow capacity. So what we want to look at is which ones are not at maximum flow. So I can see here this is 200, but this is 400. I'm missing out on 200 here. So if I upgraded this another 200 to 400, I literally would get another 200 coming through here. However, is there any other improvements? And generally when it's an S on improvements, it means there's more than one. So at the moment, let's write that one. So if we increase Hornsby to Chatswood by 200, that would increase our maximum flow to 650. So let's write that. Increase H, I'm just going to write it abbreviated. You can't, but I'm going to. Otherwise it'll take me forever. By 200 to increase max flow to 650. Okay. I don't like doing shorthand. All right, so there's that one. What else could we increase? I can see here that this is only 3. This is 50 less. So where else can I increase that? If I wanted an extra 50 here, I could increase this by 50 and have another 50 go through here and 50 go through here. That would be all right. Or I could even increase this by 50 and send 150 through here. Or I could increase this to 200 and have an extra 50 go through there. So we could either increase that one or that one. I wouldn't increase both because then we'd have too much. So let's write we can either increase Hornsby to Cherrybrook or Hornsby to Epping by 50 to increase the flow to 500. Okay, so for this one, we definitely want to increase it. This one, oh, keep pressing. This one here. But for this one, we only want to increase one of them, because if we increase both, we end up with too much down here and it's wasted money increasing it. So make sure that you use the word either if it's only one of them, or just tell them that you want to increase it. Okay. The network diagram below shows the flight path between Darwin and Wellington. I'm just going to make that smaller. Where the capacities are the number of flights each day. Which of the following would improve the flow capacity of the network? So increase the number of flights from, well, first off, let's have a little look. If we increase the number of flights from Melbourne to Sydney, so Melbourne to Sydney, if I increase this number of flights, is that going to help? Well, no. Now, where's my source? This is my source. This is my sink. Okay. The reason why that's not going to help is because coming out of my source is only 2. So even if I increase this, there's still only 2 coming through here. So that's not helpful. So let's get rid of that one. The next one says increase the number of flights between Auckland and Wellington. So if I increase this one, let's see what's coming in. Well, the only thing coming in is this one here, 5. So that's not helpful either. So no. This one says create a new flight path from Melbourne to Brisbane with 15. So a new flight path from Melbourne to Brisbane. So if I add an extra 15 here, is that going to help? Let's have a look. So if I've got 15 and 40 coming in, I've got 20 and 5. So no, because that 20 and 5 can already come from the 40. So that's not helpful. Okay, the last one says creating a new flight path from Brisbane to Wellington, which would have 15. So Brisbane to Wellington with 15. Now that would help because I've got 40 here. I've got 20 coming out and 5 coming out. So I have an extra 15 that can go down here. So yes, D is going to be my answer. Okay, this question is a tough one. All right, let's have a look at this question. So the network diagram represents a system of roads connecting a shopping centre to the motorway. The number on the edge of each road indicates the number of vehicles that can travel on it per hour. Which additional roads would increase the network capacity to its maximum? All right. A road from A to F with a capacity of 20 vehicles. So A to F. Let's look at these separately. So if we go A to F and we add an extra 20 vehicles, I'm just going to do one at a time. So A to F and 20. So what's coming in? So I've got 90 and 80. That's 170. Sorry, just get my calculator. Then I can see if I've got 55 and 115. 55 plus 115. I just have to turn my light on. Give me a second. So that's 170 there. Okay, hold on. So 90 and 80 is 170 coming in. So that's 170 coming in. 55 and 115 is 170 going out. So if I reduce that and do 20 here instead, let's look where it goes. So 115 here, 55. Now that only goes to 25, so I'm losing 25 there. No, I'm losing 30 there. So yes, I want this 20 going over here, which will increase by 20. So that will increase by 20. So that is helpful. Okay, but we want the maximum. So let's see if any of the rest are better. I'm just going to delete this so I can see a bit better. All right, so the next one says a road from B to E with a capacity of 30. So let's look at that. B to E with a capacity of 30. Okay, so remember we just said that was 170. That's got 55 coming through, only 25 coming out. So I could send 30 there. The only problem is that I've only got 20 coming out of that, and I've already got 50 going in. So that's not going to be helpful. So there's no room for outflow. That one's not going to help. Okay, let's get rid of that one then. We don't like that. First one might be it though. A road from C to F, with a capacity of 30. So we'll see if that works. So let's have a look. We've got 25 coming in and 115. So 25 plus 115 gives us 140. What have we got coming out? We've got only 20 can go through there. So that's really 20. Got 81 and 39. So 20 plus 81 plus 39. Well, that gives me 140, but only 110 can go through there. So if I minus 110, that gives me 30. So yeah, if I send 30 through there and 110 through there, I'll get my 140. So yes, that 30 works. Otherwise, I'll only have 110 going through there, won't it? So that 30 will increase. I like that. All right, what about E to F with a capacity of 60? E to F. Now we're doing both of these and a road, so we want both. E to F with 60. Okay, that's not going to work because if we have this 30 going through here and then the rest of it, so remember we had coming in 25 and 115, 115 plus 25, which is 140. So if we count the 30, the 81, the 20 and the 39, I think that gives us 140. So let's go 30 plus 50. No, that was only 20, remember, because it's 20. 30 plus 20, so that's 50, plus 81 plus 39. So that gives us the one, what have I done? No, it was 110 because we had 110 coming out plus the 30. So that's the 140 there. So if I have 140 there and here, I've got nothing extra for that 60. So that 60 is not going to be helpful. So this one will increase by 30, which is good, which is more than the first one. So we can get rid of the first one now. Okay, let's try the next one and see what it does. Let's get rid of this. Okay, so the next one says a road from B to F with 30. So let's go B to F with 30. So we already decided that had 55, 25. So that 30 is good. We do want that. So let's take that plus 30. Then the second one says D to F with a capacity of 30. Now, the reason why that one works is it goes past the 110. So this is a bottleneck here, right? We've already got 110 coming through here. Because if I add that 20, the 81 and the 39, that's plenty going through there. So because that skips it, that means I can use this one here, which is 30. So that is going to increase by 30. And then this one here, D to F with a capacity of 30. So let's look at that D to F. So that's going to be here. So if we have a look, this one's skipping from here. So this one has, remember that's 20. So we've got 140 coming in, only 110 coming out. So we'll definitely take that extra 30 there. So if we go 20, 81 and 39, that gives us the extra that we can have going through here. Let's just double check. So we go 39 plus our 81 plus 20. We get, oops, I pressed the wrong one. 39 plus 81 plus 20. I get 140, but I've only got 10 coming out. So this extra 30 would work. So this last one's going to give me an extra 60 going through. So D is going to be our answer. Okay, there's past HSC questions here now. Your solutions are online. Hopefully that's helpful.